Welcome everybody. We are going to need two items today, and that will be your pencil and your highlighter. And if you notice at the bottom of your paper, it says that you need to fold this paper in half and glue it on page 24B of your notebook. So don't forget to do that sometime. You are more than welcome to take the notes first, but at the end, make sure you glue it into 24B. And make sure that you fold it in half and glue one side in so that it doesn't hang out of the notebook. Well, we're starting a new unit, which is exciting to me. And this new unit is going to cover three things. We're going to be talking about expressions today. And eventually, in the next couple of weeks, we'll be working with equations. And then after that, right before Christmas, inequalities, which we've already done, which is less than and greater than. So it should be a pretty easy unit, and this is our first algebra unit that we're officially working on. So let's go ahead and get started. I want you to get your highlighter, and don't forget, whatever I write, you write. So go ahead and highlight the word expression. We're going to go over some vocabulary. Now, if you're looking for the success criteria for this learning target for exponents, this success criteria is on the whiteboards right next to our window. So you can take a look there at any time. But first, we're going to talk about some important words that you need to know. Let's talk about the word expression. An expression is a math problem. So go ahead and write that down. It's a math problem with numbers. And I'm going to just write the symbol for numbers instead of writing the word out. And variables. We'll say and sometimes variables, and we'll talk about what variables are. I think a lot of you probably already know. Sometimes variables, not always, but sometimes, and we'll give you some examples, okay? And this expression, this type of problem has no equal sign. Okay, it's not an equation. This one is an expression, so it has no equal sign. Okay, I'll give you some examples that I want you to write down. For instance, you could say 2 is an expression, or negative 2x is an expression, or even 7y plus 9 is an expression, or even something simple as 1/2 divided by 3/4. All of those are expressions because they don't have equal signs. They're just a problem that some have variables and some do not. So kind of keep that in mind. Well, let's go on to the next word. So I want you to highlight that next word, which is numerical expression. Numerical expression. So what is a numerical expression? Well, it's a math problem, but this time it only has numbers. So a math problem with numbers. And don't forget, what I write, you write. But this one, again, has no equal sign. So it's a little bit different than what an expression is. An expression can have numbers and can have variables. In this case, this is just something like 4 plus 7, negative 2 minus 3, 2 times 9, or maybe 12 divided by 4. Whatever it might be, it's just a math problem, but it has only numbers, so it's a numerical expression. Okay? So we have two different types of expressions, but really they all fall under one category. As long as they don't have an equal sign, then they're expressions. All right, let's highlight the next word, which is evaluate. What does it mean when I say evaluate? To evaluate something means to just simplify it, or calculate the value. I'll show you what I mean right now. Make sure you have these words written down, right? For instance, 2 minus 1. If I evaluate that, that becomes a 1. Or maybe 4d plus 3d. Well, I add that together and I get 7d. So to evaluate is to either make it simple, make it a little bit simpler, like the D problem, or just calculate the value, like subtracting. Okay, so to evaluate just means find an answer, basically. All right, let's keep going. The next one is we want to talk about a variable. What is a variable? Well, most of you already know this. A variable is a letter. So make sure you have that written down. It's a letter used in a problem. A letter used in a problem, right? Wait for you to write that down. In place of a value we don't know. So I don't know what number should go there. I'm going to put a letter instead. Right? Let me show you one. For instance, I'll put it over here. 4x plus 7. Or maybe d minus 2. Or maybe 7r. Write all of those examples down. These are just letters that are used in a problem when we don't know what the value of the number is yet. Okay? All right, so those are just some basic vocabulary words we need to know. Make sure you have all of that written down. Now let's talk about what we actually came here to focus on, and that's exponents. So when you see, oops, let me highlight. When you see the word exponent or power, sometimes you'll see that, okay? It's really the number of times the base, and you'll learn what that is right now, is multiplied. Or a fancy word, you're going to say factored. So we'll put that one. It's the same thing. Okay, so this is the exponent. This tells you how many times I'm going to write that for. Okay, that's the exponent. Or sometimes we call it the power. In fact, let's write some of these down. Like you could say 3 to the power of 2, or 4 cubed, or 7 to the 5th power. Or there's a million you can do. 1/2 to the 9th power. It's a whole bunch. But an exponent is that small number. It's a smaller one, and it tells you how many times the base is going to be multiplied or factored. So obviously, you guys need to know then, well, what is the base? Because that's an important question, okay? The base is the repeated factor, okay? So go ahead and write that down, the repeated factor. And I'll say it another way just so that you know what I'm talking about. The repeated factor, or you could say the number multiplied over and over again. Number multiplied over and over again. Okay? So let me show you where that is. This right here is the base, that big number. Make sure you draw your arrows, okay? So the base is the one being multiplied, and it's the factor being multiplied, and the exponent tells us how many times we're going to multiply that out. I'll show you what I'm talking about. So write this down. In this case, it says to write 4 3 times. So 1, 2, 3. So you have 4 times 4 times 4, right? So that is an excellent way to expand an exponent, and you guys will learn a little bit more about that. But if I multiply 4 times 4 times 4, I end up with not 12, but 64. Okay, that's really important. We're not adding, we're multiplying. So that would be 64. All right, lastly, there are 2 types of exponents that you need to know about when we're talking about a squared exponent and when we're talking about a cubed exponent. Okay, the squared exponent is to the 3rd power. So I'm sorry, to the 2nd power. So put a little 2 there. The cubed one is to the 3rd power. Okay, and we'll put some examples for you. For instance, in this case, if we say 4 squared, it's 4 to the 2nd power. Or 9 squared, it's 9 to the 2nd power. Or 0.75 squared is 0.75 to the 2nd power. Okay, you notice one thing in common, the second power. That exponent is 2. In the case of cubed, you could say 4 to the third power, or 9 to the third power, or 0.75 to the third power. Either way, it's to the third power. So there's a big difference there. Squared means to the second power, cubed means to the third power. All right, let's move on to our next success criteria, and that's writing expressions. So how do we do that? Get your highlighter. All right, here we go. The sum, that's important, of a number and 2 squared. Okay, so there's 3 things we have to write. First of all, I know that sum means addition, so I'm going to put a plus sign here. A number, well, I don't know what in the world that number is, but I know what I can use instead. I can use a variable, so I'll use n. You can use any letter you want. I use n because it says number. So the sum of a number and 2 squared, so I know squared means to the second power, so it's 2 to the second power. That's how you write an expression, right? If I give you a sentence. Get a highlighter. Let's do the next one. It says the product of 2 cubed and 33. So product, 2 cubed and 33. All right, let's get started. Product means times. 2 cubed. Okay, I know that's 2 to the third power because cube means third. And 33. We're not going to simplify them. We're just leaving them like that. Okay, get your highlighter again. Let's do another one. The difference this time, which means subtraction, of 6 cubed and 7. Okay, let's do it. So difference always means subtract, so let's put a subtraction sign. The difference of 6 cubed, so 6 to the third power, and 7. And lastly, the word quotient always means divide. So quotient of a number and 5 squared. A number and 5 squared. Okay, so quotient is the division. You could write it like this, or you could write it like that. Okay, of a number, I don't know what that number is, so I'm just going to put an n for number, and 5 squared, so that means 5 to the second power. So you can write it like that, or you can write it like that. Either way, it's the same thing, right? So now we finished the success criteria for writing expressions. So let's finish up our last success criteria. How do you evaluate or simplify these? Well, in this case, if you see this first example, 5 to the 4th power is the same as 5 times 5 times 5 times 5, okay? It is not, and I want you to write this in here, it is not 5 times 4. So go ahead and draw a circle with a line through it, okay? 5 times 5 is 25, and 25 times 5, and then you multiply that one more times 5, and you'll get 625. So this equals 625. Okay, this time we kind of have to go backwards. You see here, there's 3 x's. So we know there's 3 different types of forms we can talk about here. There's exponential form, there's expanded form, and there's standard form. Okay, standard form is the answer. Expanded form means you expand it or make it bigger. And exponential form is just the exponent. So in this case, we had x, and x. So x times x times x. So that means we have our base is x because it's a repeated factor. And our power or exponent would be 3. Okay? So really, when we multiply it all together, we still get x to the 3rd power. All right, that one's a little bit different in standard form. All right, let's do this one. Let's do the one that says 9 squared, 9 to the 2nd power. Okay? Remember, this exponent tells us how many times we need repeated addition, so 2 times. So I know I have that. I'm going to write it just like that. So I put 9 times 9. And we all know that 9 times 9 is 81. So we wrote it in exponential form, in expanded form, and in standard form. This next one that you see here, this next line, is fractions. And fractions are still okay to multiply out, I promise. Okay, so we see 3 fractions. So we know our base is 1/2. And this time I'll put a parenthesis so you can see that. and I have 3 of them, so I'm going to put to the 3rd power. Okay? In this case, 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So my final answer is 1 over 8. Let's look at the expression with a variable. In this case, I can write this out as y times y, and we're going to do that 7 times because it says to the 7th power. Okay, it doesn't mean 7y, it means to the 7th power. So in this case, it's just y to the 7th power. And last one, 1.5 times 1.5. Well, we know the base has to be 1.5 because that's the repeated factor. And so in this case, I'm going to put 1.5 to the 2nd power, squared, right? So if I multiply 1.5 times 1.5, I end up with 2.25. Okay, that's why you learned how to multiply with decimals, because you were going to need to know how to use it for these. So that's why I taught you how to multiply decimals. Now that you were done with that, you were going to go ahead and move on to your practice.